are you, everyone? Are you still confused from yesterday's class? So my plan for today is going over 3 questions from yesterday. And then we're going to start section 7.6, which is the application of rationale. And then it will be done. Any question, comments, concerns? A lot. Because our exam 3 was only based on 2 sections. So exam 4 will be a lot. Chapter 6, chapter 7. Section also 8.4. And then we'll have 10 and 11. Actually, we're done with chapter 7 almost. We have 2 more sections. And then we'll start chapter 10. So most likely exam will be 6, 7, half of. Oh no, we do 6, right? On exam 3. So 7 and 10. 7 and half of 10, I think. Even. Reflection? Or review. Over the weekend? Over the weekend? Exactly 2 weeks from today. We still have time. Reflection for exam 2, right?
Yeah.
Start. So, from yesterday's experience, I decided not to play around with many methods. I'll stick with only one method. You can get your method, whatever method you like, okay? But I'll stick with one method so that from my side, I'm safe. I wish I could have thought about that yesterday. I'm so afraid of seeing his report that I don't even want to meet him. He told me to meet him next week, Thursday. So like, oh man. I already know what he's gonna tell me. Like, I'm totally messed up too. Like, how did he mess up so many rules in one class? Okay, anyway. So one method only, the method I prefer, which is helpful for most students. And that method is bring everything to one side. Do addition, subtraction, and then at the end, solve. Okay. So we are going to add and subtract because we need to add and subtract in section 7.1 and 2. Once you're done with addition and subtraction part, then we can solve by getting rid of the denominator. So that means we want the 1/4 from the right side to the left side. I hate that. Yesterday it happened same thing. How do I change it? Somewhere here. No. How did I change it yesterday? I forgot. Not this view. Okay. So subtract 1/4 from both sides of the equal sign. So they cancel out. And we have x minus 6/5 plus x minus 5/4 minus 1/4 equals 0. Let me put a space here. Okay. So step 1, bring your unit to one side. Step 2, look for the LCD. So we have 5 and 4. What's the LCD between 5 and 4? 20. So we want to have 20 under all the fraction. So how can you convert the first denominator into 20? Times 4. So multiply top and bottom by 4. The second denominator, we multiply top and bottom by 5. And this is also by 5. Once we have all the denominators, we are ready for combining the numerators. And as you observe, these are distributions. So we get 4x minus 24, then plus 5x minus 25, and then minus 5 equals 0. Do we have any like terms to combine? 4x and 5x. Combining them, how many get? 9x. And then we have negative 24 minus 25 minus 5. Negative how many? 30? No, negative 30 minus 24. Negative 30 minus 24. 54. So we have negative 24, negative 25, negative 5. Negative 5, negative 25 gives us negative 30. And you're also subtracting negative 24. That means you're adding them. So 54 divided by 20 equals 0. Now, can you factor out anything from the top? 9. So we get x minus 6 equals 0 divided by 20. Can you cancel 9 and 20? No. But we definitely don't want that 20. So how do you get rid of the 20? We multiply both sides by 20 so that numerator 20 and denominator 20 cancel out. And we get 9 x minus 6 equals 0. Actually, let me do it here. So we have enough space. Take out 9, we get x minus 6 equals 20. We don't want the 20, so we multiply both sides, they cancel out. We get 9 x minus 6 equals 0. Then what do we do? Huh? Our goal is to get the x alone. So that means we don't need the 9 in the front and negative 6. Which one you get rid of first? By doing what? Addition, subtraction, multiplication, division. Good, division. So we don't want that 9, we cancel out. We get x minus 6 equals 0. We just need to add this 6, and we get x equals 6. Since none of the denominator has x, so we are safe. If denominator has any x, then we needed to see that x cannot be what number? But the denominator cannot be what number? So for now, there is no x in the denominator. It's just a number 20. It's fine. Any question? What did you do? Not denominator, right? You multiplied numerators. Since this is shortcut, let me just show you. So x minus 6 over 5 plus x minus 5 over 4. Did you bring everything to one side? Minus 1/4 equals 0. So C said, I'm going to stick with my method, but I can also show you, no problem showing you. If you don't want your denominators, it can get you the denominator in the second step. How? By multiplying every term, every numerator by your LCD. So you multiply this by LCD 20, this by 20, this by 20, and also this by 20. You multiply everything on both sides of the equal sign by 20. What happens then? 5 goes to 20 4 times. 4 goes to 20 5 times. 4 goes to 20 5 times, and 0 times anything is 0. So what do we have? 4 times x minus 6 plus 5 times x minus 5 minus 5 times 1 equals 0. Number denominators, you're not worried about the denominator. But this side has downside, this method. If you had x on the denominator, then you had to check what is your x, or what is your x cannot be. You must have to consider that. And then you distribute it, right? Right, Robert? So we did here on the left side, 4x minus 24 plus 5x minus 25 minus 5 equals 0. That gives us 9x minus 54 equals 0. So x is 54 over 9. I'm doing shortcut. 9 goes to 54 6 times. So your x is 6. Question? See here, I factored the 9 out because sometimes when you factor out something, you can cancel the denominator. And if something gets canceled the denominator, you don't have to worry about having an extraneous solution. So in the next one, they already have it to one side. So I'm going to stick with my method, and then I'm going to show you Robert's method, why I don't like the denominator. So first step, always look for LCD if everything is on one side. What is the LCD between x and x squared? X squared, the bigger one. So we want a big x squared, which we don't have. That means we need to multiply by what we don't have. What we want below 5? X squared. So we multiply top and bottom by that. We have x on the second denominator, but we want x squared. What to do? We multiply by x, numerator and denominator. Do we have anything wrong with the third denominator? So we don't touch. If you don't have any problem, don't touch. So all the denominators are x squared, x squared, x squared. You're happy. We go and combine the numerators. 5x squared plus 2x minus 3. And then what? Factor. So if you do want a factor, which method you have to use? Good job, AC method. So 8 times C gives us 5 times negative 3, which is negative 15. Two numbers multiplied to negative 15 combined to positive 2. 5 and 3. Are you sure? What sign you have in the middle? 5 has to be positive, 3 has to be negative. And let me use my shortcut. Okay? Once you figure out this, you write them into parentheses, plus 5 minus 3. And instead of x, you write 5x on both. So you split it x squared into two pieces, x and x, and you keep your 5 on both because our goal is to take out the GCF. From which one we can pull out a GCF? The first one. What's the GCF you see? 5. So we factor out 5, we get x plus 1. And we have this, so we keep it 5x minus 3. And then you completely ignore your GCF. And that's it. X plus 1, 5x minus 3 divided by x squared equals 0. If you don't like this method, no problem. Use your traditional AC method. Can you cancel anything from the numerator and denominator? We cannot. That means we can get rid of the denominator by multiplying both sides by x squared. So x squared cancel out, x squared. And we get x plus 1, 5x minus 3. What is 0 times anything? 0. X plus 1 is 0. 5x minus 3 is 0. X is negative 1. And x is positive 3 over 5. And here actually two methods are same. Once you combine the numerator, the only thing you can do is multiply everything by x squared to cancel the denominator. So I don't need to show you the second method. Stephanie, what question you have about the AC method?
I found my.
Okay. Okay, then we have one more to go. Yvette. We do, thank you. So we want LCD not to be 0 because LCD has all the denominators. So if you check your LCD, you're safe. Our LCD is x squared. We don't want x squared to be 0. Take the square root. So we don't want x to be 0. This is what you don't want. So you don't want x to be our answer. And we do found x equals negative 1 and 3/5 as our answer. Sometimes what you don't want is that we see them here. You see them here, disregard. For example, if you don't bring everything to one side, and if you don't follow the way I did, and let's say you want to get in the denominator fast, I'll show you what happens then. So let me use this. Let me do this using the second method, where you get you the denominator before you even do anything else. If you follow my method, add and subtract, simplify, and then solve, you don't have to check. Like here, you don't have to check. Because the two answers we got, none of them are 0, you're safe. But what I'm going to show you, if you use this method, you must always have to check. So method 2, getting rid of has how many F? 1 or 2? 1 of 1F? Okay. Getting rid of the denominator first. No, I'm showing you a method. If you get rid of the denominator first, what happens then? Before you go for the denominator, before you get to the denominator, what do you observe in the denominator? Perfect square. Not only x square, it's a perfect square. So what are the two factors we get here? X plus 6, x minus 6. So let me rewrite. We have x. Oh, I need more space, so let me write it down. We have x over x plus 6. We have 72 x plus 6. We have 4. Right? This is what we have. And now, last thing we want to do is get rid of the denominator because we don't like that. I don't want you to use this method, but I'm showing you, if you do use it, what happens then? So if you don't want the denominators, that means the thing you can do is multiply every numerator by LCD. So we need to see what is our LCD. So what is the LCD between x plus 6 and x plus 6, x minus 6? Right, in a LCD well. X plus 6, x minus 6. These are also, actually, let me write the LCD here. X plus 6, x minus 6. So I have my space here. So if you don't want your LCD, if you don't want to denominate that, see all this time, if you don't want the denominator, multiply by LCD. We did that before. So we're going to do this again. Multiply the numerator by LCD, denominator will disappear. So x plus 6, x minus 6. X plus 6, x minus 6. X plus 6, x minus 6. Multiply every numerator by LCD because we don't want the denominator. We are getting rid of the denominator. So you can put x minus 6. No, I'm not making the denominator same. Instead, I'm getting rid of the denominator. So the x plus 6 from the first denominator get vanished. X plus 6, x minus 6 from the second denominator get vanished. Do you see any more denominator anywhere? No. This is what it means, getting rid of the denominator first. We multiply all the numerators by LCD so that there is no more denominator. And we rewrite. First numerator gives us x and x minus 6. Right? This is what you left. What do you have in the second numerator? Only 72. And what do you have in the third numerator? 4x plus 6, x minus 6. Do you have any denominator here? No. So we're supposed to be happy. Supposed to be. Okay? So we solve just like normal polynomial. We distribute. What do you get? Minus 6x. And here's 72. Before distributing, we need to multiply these two. So we get 4. If you multiply to conjugates, what do you get? You're multiplying this. So if you multiply them, what are you supposed to get? X minus 36. If you don't see it, no problem, use FOIL. But if you want to save it time, don't use FOIL. Just see Why did you get the x plus 6 minus 6? Because we factored that. That means we multiply the x plus 6 and minus 6, you're supposed to get the same factor back. And then you distribute 4 times this, 4 times that. So we get x squared minus 6x equals 72 plus 4x minus 4x squared minus 36 times 4, 144. And now it became a simple quadratic equation. So in order to solve, what do you want to see? Solve something, you always have to see something what? 0 on one side. Do you have 0 on one side? So you must bring something. Do you bring left to the right or right to the left? Left to the right, it's easier. Because we have 4 of them here and only 1 of them here. So keep your 4. Bring the smaller one. So subtract x squared, subtract x squared. Add the, doesn't have any x. So you just put x anywhere. So cancel, cancel. We get 0 equals 72. Oh, we can combine these two, right? 72 minus 144. 4 minus 2 is 2, 14 minus 7 is 7. So 144 is 7, 144 is negative, 72 is positive. We're supposed to get negative 72. So negative 72, and how many x squared? Positive 3x squared. Anything else? What happens to the 6x? Plus 6x. But the order is wrong, right? So let's rewrite them in correct order. 3x squared plus 6x minus 72. We cancel from the left side, but you still have it on the right side. And then what do we do to solve? Oh. Before you go for AC, anytime you factor, what is your first step? GCF. Do you see any GCF? We know 3 is divisible by 3, 6 is also divisible by 3. How about 72? It is divisible by 3, it's 12. If you don't know, you can do it here. 3 goes to 7 twice, we get 6. 1 of 12, 24. So we get 1, we bring down the 2. So 3 goes to 12 4 times, and we have the answer 24. So you factor out 3, or you can divide everything by 3. Let's divide everything by 3 because all of these are divisible by 3. Divide by 3. Divide by 3. Plus 2x minus 24. And now I like it very much. It becomes a simple quadratic equation. Can you factor this? 2 numbers multiply to negative 24. 6 and 4. How about their signs? 6 has to be plus because of this. That means 4 has to be minus. So we have x plus 6 equals 0, x minus 4 equals 0. That gives us x is negative 6, and x is 4. You factor out 3 and then you divide by 3. Now, this is a multiple choice question, okay? So you see, this is a multiple choice. Oh, I get my answer correct. So you circle it, And then you're happy, you got your points. Guess what? You get 0. You know why? Because you did not check yourself. Remember, LCD cannot be 0. So whatever we have here, that thing, let me change color to something different, purple. That thing cannot be 0. So x plus 6 cannot be 0. X minus 6 also cannot be 0. None of the things we have on the LCD can be 0. None of them. That means x cannot be which number? -6. And x cannot be what else? +6. So there are two numbers you definitely cannot substitute for your x. But you're telling us that, hey, one of the solution is x equals -6. Can you accept x equals -6 as your solution? No. So see the problem? If you get rid of the denominator fast, you're losing all the points for the entire solution. So you did all of these for nothing. Unless you don't forget to check your denominators and disregard that from your solution, which most people forget. They ignore the denominator, they see the answer, they're like, oh, we're done. And then they pick the answer from the answer choices. You're not going to see this, you're not going to face this problem if you simplify fast and then solve. So if you use the fast method, we bring everything to one side, just like addition and subtraction, combine them, simplify them, and then solve them, you'll see that this will cancel out before you even go for solving. So the only answer you can get is x equals 4. Can I show it? Only 4. So you have two ways of doing it. Either you do the way I did, observe your LCD and figure out what you cannot have in the solution, or if you forget that, make sure you check both solution in your equation. So equation was x over, so I'm doing checking, okay, in case you forget. Now everything is done. Come on. I still have them. No, I don't. You get the solution, right? Because I lost everything. But let me show you. So we have, I'm checking. We found one solution is x equals -6, and another solution is 4. So how do you check? You have x over x plus 6 equals 72 over x plus 6, x minus 6 plus 4. When x is 6, -6, what do you get? -6 over -6, +6. You don't even have to go any further. You see 0 here. You get -6 over 0. It's automatically undefined. So if one of the term is undefined, at least one, everything is undefined. So x equals -6 cannot be answered. Then you check x equals 4. When x is 4, we have 4 over 4 plus 6 equals 72. 4 plus 6, 4 minus 6 plus 4. 4 plus 6 is 10, we are safe. 4 plus 6 is 10, 4 minus 6 is 2. 10 times 2 is 20, we are safe. So this is safe. For 4, none of the denominator is 0. But for -6, the very first denominator turns out to be 0. But we cannot have 0 on the denominator. Huh? You can use like it's a way to test two methods. Coming from this for this like so you want to do this using first method where you keep your denominator. Okay, no problem. One, two, okay. Keep denominator, simplify, no, add, subtract, simplify, and then solve. This is what we are going to do here. Go ahead, send this.
So for the second one, we have to show our work.
You always have to show your work.
Not show our work, check.
Unless you use the first method, you always have to check your answer. So when you check, there are two ways. Either you check at the end like this, or you check using your LCD. But you have to check either way. Either check it at the beginning, what you cannot have in the solution, or do it at the end to see the solution you got. Do both of them work? Somewhere you have to check your work, somewhere. But if you do this method, like you add and subtract, simplify fast, you don't have to check. Because when you simplify, all the problem gets solved. That's it. That's what I told you before. If you don't check, see what happens. If you say your answer is -6, +4, your answer is wrong, so you get 0. So you have to check somewhere, either at the beginning or at the end, or do this method where you add and subtract, simplify fast, and then solve. If you simplify, you don't have to check because all the things you did, the problem, the simplifying, solved everything. Jolene. But we didn't get -4 as our solution. We got +4 and -6.
Somehow I got like +6.
When you factored, what are the two factors you have? The two factors. What factors you got after you factor at the end? X plus 6 and? Huh? No, the two factors you got. Look at your paper. Look at your notebook. Before you solve, what two factors you got? Not here. I lost all of my work. Okay, so my work is not there. I'm talking about your notebook. Look at your notebook. At the very end, what are the two factors you got? Don't think. Look and tell me.
No, I didn't.
You do anyway, and it doesn't matter. At the end, you get two factors, right?
The final.
Right.
3 and then x-6 and x plus
3, x minus 6, x plus 4. Now, how do you get x minus 6 and x plus 4? What do you have before that? What was your polynomial? X squared and then?
x squared minus 6x minus 7.
Minus 6x minus 72. Why do you have minus 6x?
When you factor, let's say, I did it the first way because x, because I have to times it by
Well, let's do this way, okay? And then you will see who is wrong, you or us. Because you get +6, but you get -6.
Okay.
That makes a huge difference. But let's do it together. What I'm doing, I need my question. X over x plus 6, 72, x plus 6, x minus 6, and then +4, right? This is the beginning. So I want to bring everything to one side. That means we're going to subtract x over x plus 6 from both sides. They cancel out. We get 0. And then 72 x plus 6, x minus 6 plus 4 minus x over x plus 6. Oh, I need more space. So minus x over x plus 6, right? And then I'm not going to get you the denominator. Instead, I'm going for LCD. What's the LCD? X minus 6. Now remember, I'm not going to get you the denominator. I want to add and subtract, simplify, and then solve. That means we want the denominator's LCD on every denominator. Do you have LCD on the first denominator? So yes, see. Do you have LCD on the second denominator? No. So we want our LCD here. X plus 6, x minus 6. X plus 6, x minus 6. Do we have our LCD on the third denominator? What is missing? So multiply by x minus 6. And now you're happy. All the denominators are same. So we combine the numerators. So 72 plus 4 minus 36. And then let's also multiply, keep this. And we have 0. So 72 plus 4x squared minus 144. Ta-da. And then we have negative x times x, negative x times 6, negative 6. So negative x squared and then plus 6x. I still have my denominators, which I want to keep. And let's see, now comes simplifying. Plus 4x squared minus 1x squared. How many x squared we have? 3x squared. And now Julian and we have problem. We have plus 6x. And Julian, what do you have? That's a mistake. We're supposed to have plus 6x. And then at the end we have plus 72 minus 144. So when you combine, negative 72. I still have my denominator, which I still want to keep. And we've seen before we have a GCF, so we pull out the GCF. X squared plus 6x minus. I still have the denominator. Wait, 2x. Thank you. And I still have everything. I just want to factor the numerator. So what are the two factors? Plus 6 and minus 4. And now what do you observe? See, if you keep everything same, you add, subtract, and simplify, the problem we had before automatically gets solved. Since this is cancelled out, we don't have to worry about getting an answer that doesn't make sense. That's what I said. If you add, subtract, and then you simplify, then you solve, you don't have to worry about checking. that already solved your problem of checking. Say 3 x minus 4 over x minus 6. And now we don't want the denominator. We simplified first, and then we get to the denominator. How do you get to the denominator? Multiply. Say multiply x minus 6, x minus 6. No more denominator. We have 0 equals 3 times x minus 4. Only one solution. We don't want the 3, so we get rid of the 3 first. Because 3 doesn't have any x. If 3 had an x, we kept it. But 3 doesn't have any x, so it's useless. So I get 0 equals x minus 4. So what is our answer? Only one solution, x equals 4. And which is a valid solution. We don't need to check because that solved our checking problem, checking issue. That's why I like this method. Because if you do your addition subtraction fast, solving is, you can solve smoothly. So yes, in the exam, you're going to see at least one question. I mean, in the in-class exam, 2 questions, but in the final exam, at least 1 question. And that question sometimes has 2 solutions, sometimes has 1 solution. It depends. Question, comments, anything? So now you know how to solve equations, critical equations, not really rational. Now, why do you use them in real life? Why do you care? Well, I care because you actually use them a lot without even realizing it. Let's say you have this type of problem. You know 2 persons. You hired 2 people, okay? One of them works fast. He can paint your room in 9 hours. When the 9 hours is a bit long, but still, let's say a big house. He's painting a big house in 9 hours. And then the second worker you hired, he was lazy. He painted your house in 12 hours. Remember, the more hours they work, the more you have to pay them, right? So you get an idea. Well, one of them is faster, one of them is slower, but they both have some good qualities. So you don't want to fire any of them. So what if you put them together and see how long it takes if they work together to finish painting an entire house? Real life scenario, right? So how do you solve them? You can solve many different ways, but I'm going to show only one method, only one. And this method, all you have to do is remember this formula. The formula says, it doesn't matter how many people are working, it's 1 over the time the first person need plus 1 over the time second person need plus 1 over how many people you have, the individual time. If you add all of them, the result is 1 over what if they work together, how long it takes if they work together. So sum of their individual time as a fraction equals 1 over together. That's all you have to remember. And one of this question will be in the final. So in our case, we have one lazy guy and one faster guy. So what do you have? 1 over 9 plus 1 over 12. And do you know how it takes to work together? No, you don't know. So whenever you don't know anything, it's X. We definitely know the first person is 9 hours, the second person is 12 hours. We don't know if you put them together. It's not 9 plus 12. You put them together, some miracle happens if they don't chit chat. Okay? So we want to know how long it will take if they don't chit chat. Will it take longer or will it take shorter to done the same job? So we have a nice looking rational equation 1 over 9 plus 1 over 12 equals 1 over x. Now this scenario is a little bit different than what we did today so far, right? What we did today in the last 2 or 3 examples was we had x on both left side and right side. Do you remember that? Did you notice that? We didn't. So we had x on the left, x on the right somewhere. But here we have only a single x on one side. So if you have a single x on one side, you don't have to bring everything to one side because your x is already alone. So what you need to do is simplify the other side. And then that will tell you what your x will be. So we combine these two. We need our LCD. What's the LCD between 9 and 12? Huh? 108 is a multiples, but not the smallest multiple. What did you say? 36. The smallest number, which you can divide by 9, and also you can divide by 12, is 36. Even, how did you figure that out? Timetable. So if you don't know, no problem. You look at the timetable. 9 timetable has 9 times 1, 9, 9 times 2, 18, 9 times 3, 27, 9 times 4, 36. And let's see, before you go further, let's see what 12 has. 12 timetable has 12 times 1, 12, 12 times 2, 24, 12 times 3, 36. Do you already see the same number on both timetable? 36, right? That means our LCD is 36. So if you don't know how to find LCD, write down your timetable, and then the smallest number you see in all the timetable is the LCD. That means we want 36 on the 9 and also on the 12. What do you need to do to convert 9 into 36? Times by 4. So multiply top and bottom. And how about 12? Times by 3. And now you're happy, you have 36, 36. So we go ahead and combine our numerators. 4 plus 3. And what is 4 plus 3? So we have 7 over 36 equals 1 over x. True. So you're almost done. There's one problem. X is on the denominator. We want x in the numerator, not on the denominator. Would you cross multiply? We don't have to. If you do flipping. So you flip, you get x over 1, and you get 36 over 7. But x over 1 is same as x. 1 is invisible. So we get 36 over 7. And you are done. But you don't know what is 36 over 7, right? So you have no idea how long it takes. So let's do division and see actually how long time it takes. 7 goes to 36 how many times? 5. 5 times 7 is 35. We subtract, we get 1. So we put a decimal here, and the 1, we can turn this into as 10. Now 7 goes to 10 how many times? 1. We get 7, we get 3. You can keep going on, but you already got some idea. How long it takes it to work together? 5 hours. And then a little bit more. So see the miracle? Lazy guy takes 12 hours. Faster guy takes 9 hours. But if you put them together, it reduces down to only 5 hours. So you're paying for only 5 hours, plus a little bit more. If I would have put this 5 hours, would I have still got it? Yeah, if you have a fraction and then this, it's fine. So this is for you to see like actually how long it takes. But in the exam, if you see multiple choice as a fraction, keep it. You don't have to do anything else. Any question? Okay, now you have two questions to do by yourself, but before you do them, let me introduce you to the second topic that comes in the final exam sometimes. Are you guys done copying? So the second topic comes, it's about boat problem. You're going somewhere with boat. So when you are going there, you're going with the current. So you have a faster speed. But when you come back, you're going against the current, so you have a slower speed. They're asking, what is the speed of the current? Sometimes they ask, what is the speed of your boat? No problem. This question. So this is your current. This is your water. You are here, you're rowing, and then you're going with the current. So speed of the current is going to one side, and your boat is going to at the same time, and you're sitting somewhere here. When you go with the current, you're crossing 48 miles in 4 hours. But when you come back, this is still your water, this is still you are, but this time you're coming back, so you're going this way, but your current is still flowing to the other direction. And still you're crossing your 48 miles. But since you're going against the current, so it takes longer. How longer? 6 hours. 6 hours. And you're here, tired, because you're coming back. The question is, what is the speed of the current? Did you understand the scenario? Is there anybody who did not understand the scenario? Think about real life. You're going somewhere and you're going with the wind if you're driving, and you're going with the current if you're on water. So you're moving faster. Your speed plus the speed of the current, the speed of the wind is moving you faster. So it takes only 4 hours. But when you come back, you're going against the wind or against the current. So it takes longer because of the friction. What is the speed of the current? So finalize the question. Finally. Sometimes they give working together, sometimes they give the boot problem. Now, how do we start is we start by speed. Let's say B, the speed of the boat, and C, the speed of the current. And what is speed? The distance you cross over how long time it takes. So the formula for speed is distance over time. So the first scenario is telling us that your speed means your boat speed. Your boat speed plus the current speed, when you have them together, you are crossing 48 miles in 4 hours. Right? This is the first scenario. Your speed plus the current speed, you're moving 48 in 4 hours. So what's the speed? The total speed, the sum of the speed. You have 48 miles per 4 hours. So what is your speed? 12 miles per hour. Right, this is how you find the speed, distance over time. Now the second scenario is your boat speed.
You guys help in dividing it?
Yeah. That's how we find the speed. It's distance divided by time. So we are crossing 48 miles in 4 hours. So what is the speed? 12 miles per hour. Now the other scenario, your speed and the current speeds. What is happening this time? Are you going with it or against it? Yeah. So against means what sign? Plus or minus? Right. Minus. Because one is pushing this way, other is pushing that way. So we have a friction, which is a minus. And this is happening. Crossing the still same 48 miles, but this time it takes 6 hours to cross 8 miles per hour. So you have your two equations. The speed of the boat is B, speed of the current is C, gives us 12. Speed of the boat minus the speed of the current is 8 hours. So we have two system of equations. How do we solve them? Substitution you can use, but I will go for elimination. If you add them, C gets eliminated. Our life becomes easier. How many B's we have? 2B equals how much? 20. And then what do we do? By 2. Good. So speed of the boat is 10 miles per hour. But we are not looking for speed of the boat. They ask how fast is the current. Means what is the speed of your current? So if you know your boat speed, can you figure out the current speed? See, we have boat plus current is 12. The boat is 10. Then what is current? 2. You can do the second equation, but I didn't like it because my C is minus. So that's the answer. And with these, we are done with the word problems. 7.6. But now you are going to do two questions. Any question on this one? Which part do you think is the hardest to remember or figure out?
In this question or
in this question? Is this making up the equation or solving the equation? Making the equation. The pictures. Do the pictures help to figure out? No? My pictures are bad. Anyway. But yeah, anytime you have something with speed, try to connect with real life and see what happens. So here I connected your boat and speed boat. Since you're going toward the same direction, you add them and you get your speed. When you go against them, it's the one against another. So you need to subtract the smaller speed from the larger speed. What do you think? Who has the highest speed? Your boat or the current? Which has higher speed? Real life. Think about real life. You're going somewhere.
the current, if you're going with the current,
It doesn't matter you're going or coming back.
you with the current.
So who has higher speed or faster speed? Who has faster speed? Your boat or the current? Both. That's why it's subtracted here because both must have higher speed, the faster speed, right? In real life, unless it's in what's called tornado. If you have a tornado, definitely tornado has higher speed, faster speed. But this is normal scenario. Jolene. No. I showed you need to see the real life scenario. Robert? System of equations from? These are real life problem. Say it louder. 4.5 we work to it quadratic, right? It's or rational. Word problem. So every word problem is based on the topic we learned. So here we learned rational. So these word problems are about rational. Chapter 6 we learned quadratic. So word problems are on quadratic. And what is chapter 4? System of equations. So yeah, they're similar because we did system of equations. Okay, you have 2 questions. Do that and then you're ready to go. Let me take the attendance. Oh, before you go, make sure you have your homework for Tuesday. If you haven't done 7.1 and 2, it's 7.1, 7.2, 3, 4, 5, 6. And this is 6, right? Yeah, the next one is 7 we're going to do later. So you have 1, 2, 3, 4, 5, 6 homework, including all of their quizzes on Tuesday. Tuesday. Oh, and Monday you have no school. Why is no school? Probably it's the holiday. Muslim holiday. Probably. So yeah, even if you don't see them, I assigned on my MATLAB, it doesn't matter. You still have to do them. See, I'm so busy. I don't have time to keep changing the deadline for every homework. So I forget to do them. These 6. And you're only supposed to do 1 and 2 for exam 3. But if you haven't, no problem. I'll open them again. Okay. Attendance. I wish yesterday's class went as smoothly as today's class. Man. It was so bad when I think about it. It makes me angry. Brian Almonte here. Christina here. Catherine absent. Jolene here. Govan here. Govan, you were absent yesterday, right? Yeah. Madison Fields. Eric. Abraham. Stephanie here. Leandra, wow. She was never absent. Robert here. Katie. She was also never absent. Oh man. Probably they're going somewhere together. Because they both are never absent. Kimelsia absent. Maria absent. Sandy's here. Michaela no more. Madison Orlando no more. Madison Field absent. Angie. Wow. Mezavin here. Melville is absent. Giselle here. Giselle, you still have your perfect score. Attendance. Muhammad here. Tahsin here. Gavin here. Brianna, Texas. You also have your perfect score. Attendance. Carla absent. Yvette here. Nicholas here. Wow, Nicholas, you have your perfect score, attendance score. Daniel absent, Hassan absent. I love to see perfect attendance. What happens then? At the end, if you guys are off for few points to the next grade, I actually boost your grade because you are so great. You attended every single class. So I was thinking of doing something for you. So I do that for perfect attendance people. Without, even in general, you guys are never absent. You, text, Brianna, and Nick. Yeah, still you can have 4, but actually no. When I see perfect attendance, like perfect, it makes me feel so proud of you guys. Are you guys ready? Okay, so let me check. Did you say the rule? So if you remember the 1936,
Oh, that's all.
One of our time on the and then you also so this is like 19. We find it out 19, not now. So 80 else is fast. Then add fractions till there is 1,000. So 50 dollars is like you can see. Then I can do it. I'm not combine them. So this is also you can see. Right on the pattern for line. Yes. And then what you have? Why do you have to do what you do? If you see this one, combine with that for what? You know what? One times here. That's still a combined first. No, I just wanted to. No, so one of our. whatever goes, whatever case, I mean, whatever you don't know, yes. What is true? That's what it says. What you don't know here in the second equation. The time for the second partial or time for the together. It's what? Which one is missing in the second equation? So whatever is missing, that's less. 19 over 18 is the single bar. What do you see here? This is 4. 9 6 and 4. Now, this one, what is missing? What is missing? That's the X. What is missing? Second one. Executed reflex. I didn't look at it. I was just special. I don't know how to go. I think this is the scenario. What is that? What is function? Why is the function? This one is always. If you will, in Sec7.5, I just had a small what are you trying to say? It's 112. Isn't that story? Is it that or it's fine. Is it? What else? Yeah. Oh, wait, don't you have to what is missing here? Remember, 2 is for 2. Exactly 2 is for 2 is in that exam. Got it?
Oh.
Really fast confident as well. And then what's the next sentence? Yes. Sorry. Formula always at 1 over something, 1 over something. Now, but we have both sides. It is individual. Time for individual. Whatever you see, is always different. Now, in here, on this side, you know, the time for the first couple, it's 1 over here. Doing the time for the second so, on this here, what is the how do you do this? Do you know how long it takes to work together? Isn't this like a lot of
Yeah. Yes.
Students over time, let's get together. The common mistake I noticed that you guys thought they are the same question. Definitely they are not same question. That's why I gave two questions. We already know the first one, so let me skip the first one. Let me do the second one. In the first one, they gave you all three individual person, but in the second one, they're telling us first custodian needs 4 hours. So it's for the first person, 1/4. Then suddenly they're saying that, well, if a second person come in, it takes it takes 2 hours together.
Would it be like 1/2 plus 2?
Every time you have together, it has to be single on the other side. Together is always single in one side.
So then the middle would be 1/x.
Exactly. So we don't know for the second person how long it takes. The single job, see alone, we don't know the single job. So the single job we don't know, so it's 1/x for the middle. We have no idea this person, how long it takes. But they give us the information for both. They give us the information for the first person. So it's 1/4 plus 1/x equals 1. And now since 1/x is the only variable we have, so let's keep it in one side because our goal is to flip it. So let's keep it so you can flip it. It rhymes. Let's keep it and subtract 1/4 from both sides. So minus 1/4, minus 1/4. They cancel out. We get 1/x equals 1/2 minus 1/4. We need the LCD. What's the LCD between 2 and 4? 8 is multiple, but not the LCD. So you ask yourself, is 4 a multiples of 2? Yes, that means that's the answer. 4. You can use 8, no problem, but you have to simplify that. So that means we want 2 here. So you multiply top and bottom by that. And we get 2 minus 1, which is 1/4. So let me do it here. 1/x is 1/4. So you flip to make your life easier. That means you also have to flip that. X equals 4. Oh, see? Not bad. Most of the time they give this question in the answer in final. What is the answer for the left one? What about what? Give me the fraction. Fraction is fine. 36/19. If the multiple choice has decimal, you divide. If multiple choice is a fraction, leave it. And if it's not a multiple choice, fraction is fine. I will not punish you. Exam reflection Tuesday. I didn't print them. I didn't have time to print them. So have a good weekend, everyone. Don't forget to do homework and quizzes. Bye. Be safe.